These are our notes for section 8.1, and so this is going to be the A video, and we're really going to talk about what is a polynomial and how to add, subtract, and multiply polynomials. So let's start off by defining what a polynomial is. We talked about monomials in our last unit and how that a monomial was a single term. Polynomials are mathematical expressions with two or more terms. Let's see if I can get my pen to write. Here we go. With two or more terms. So two or more things that are being added and subtracted together. If you look at these examples down here, this is a polynomial plus another polynomial. We can also be a little bit more descriptive than that. If there are two terms, we would call that a binomial, bi for two. If there are three terms, like in this example right here, that would be a trinomial. So in this one, this is going to be a trinomial minus a binomial. So it's just kind of vocabulary. It's not something you're going to be quizzed or tested on, but it is helpful to know if you see it in directions and things like that. So the good news is that you have been adding and subtracting polynomials for years, because adding and subtracting polynomials is simply combining your like terms. And as a reminder, like terms are things that have the same variable or variables, and each variable has the same exponent. So some of our like terms are going to get a little bit more complicated than they were in years past, but it's still the same idea. And you saw this pop up if you did the medium assignment from the 7.2 choice board, where the first three problems involved combining like terms or adding and subtracting polynomials. When you are multiplying a monomial, a single term, would you like to be a guest appearance?
Oh, sure.
All right, when you are multiplying a monomial, which is a single term, by a polynomial, you're just distributing. And so when we're doing this distribution, you're going to need to remember your exponent rules from Unit 7. So if we're multiplying two things that have the same base, we're going to be adding those exponents. So we're really starting to put a lot of different pieces of things that we've worked on in the past all together here. The last thing is that when we're writing polynomials, we need to make sure that our final answer is in standard notation. And again, this is something that we touched on before, but standard notation means that your variables are in alphabetical order, and the exponents are in descending order. When we talked about standard form in Unit 7, we did talk about the alphabetical order. We'll get into, with the examples and writing them, a little bit more about what I mean by exponents in descending order there. So let's get started with some examples. So we're looking to see what our like terms are, and those are going to be the things that we can combine. So in this first example, I have 2x plus 3y plus 4x plus 9y. The parentheses are here to show us that originally these two were grouped together as a binomial and these two were grouped as a binomial, but when we're adding, the parentheses really don't matter. So I have an x to the first power here, and I am going to be able to combine this 2x with this 4x right here. The other two terms have y's. So I'm going to change colors. Let's go with green. So I'm going to be able to combine my 3y with my 9y. When we're combining like terms, we're just adding and subtracting coefficients. So 2x plus 4x, 2 plus 4 is 6, so this is going to be 6x. 3y plus 9y, 3 plus 9 is 12, so that's going to be 12y. So now as far as putting it in standard form, my variables in alphabetical order, x, then y, and I don't have any other exponents, so I don't need to worry about this descending order on my terms. So that's my final answer right there. And the next, I have a trinomial. I have 3 terms minus 2 terms, minus a binomial. Again, I am looking for what my like terms are. Those are going to be the things I can combine. Subtraction is a little trickier because we have to remember that we are distributing this subtraction to both of these terms. I am subtracting 2d and I'm subtracting 5. So when we're doing a subtraction problem, the first thing that we want to do is distribute that subtraction by flipping the sign of each of these. So this is going to end up being minus 2d minus 5. Nothing in the first one changes. Now I'm looking for my like terms. The d squared does not have a like term. This negative d and the negative 2d are both like terms, so I'm going to circle those in the same color. And I'm going to circle this subtraction so that I know that it's attached to the 2d. My other like terms are my constants, so this positive 5 and this negative 5. So those are the other things I'm going to be able to combine. So the d squared didn't have a like term, it stays by itself. Negative d minus 2d, so negative 1 minus 2 is negative 3d, and 5 minus 5 is 0. So I don't need to write plus 0, that doesn't change anything, so I'm going to leave that right there. All right, we have 2 more examples. This is another subtraction. This is a trinomial minus a trinomial. So again, with subtraction, we need to take the time to do the extra step of distributing the subtraction to each of these things. So this is going to be minus 7x cubed minus 5x squared and plus x. So we're going to go ahead and write that down so that we don't forget it. Because subtraction of a negative, or subtracting a subtraction, turns positive. This first parentheses doesn't change. It's not affected by the subtraction, only what comes after it is. And now we're going to look for our like terms. So this first term is x cubed, and it can be combined with other x cubes. And that negative is with the 7x cubed. So I'm going to circle them both. I can combine the x squared term. So this is a negative 3x squared and a negative 5x squared. So those can be combined. There are no other x to the first power, so the 5x is not going to combine with anything. And there's no other constants, so terms without variables, so the 12 is not going to combine with anything. So when I go to write my final answer, I'm combining 1x cubed, so 1 minus 7x cubed. 1 minus 7 is negative 6x cubed. Negative 3 minus 5 for the x squareds is negative 8x squared. And then these 2 terms that had no like terms are still part of my answer. They just didn't combine with anything. So my final answer ends up having 4 terms because those were the only things that I can combine. So it's not always going to be that everything matches up with another pair. This example is our last example with addition and subtraction. This is addition, so I don't have to worry about distributing anything. I'm just going to go through and look for my like terms. So a squared has another a squared right there. So I'm going to be able to combine those, a squared and 4a squared. AB, I'm looking for other terms that have a to the first power and b to the first power, and I have one right here. So let me change colors so that all my like terms are circled in the same things. And then the last term in this first trinomial is a b squared, and this is also a b squared. So this one, everything had something that it could kind of partner up with or pair up with. We'll go blue. So negative 3b squared is going to combine with that positive b squared. So adding together the a squareds, 1 plus 4 is 5a squared. 1 minus 1 is 0. Those cancel each other out. I have no ab in the answer. I don't need to write anything there. And then negative 3 plus 1 is negative 2b squared. So those are all of our examples with adding and subtracting polynomials. And again, it is just really goes back to that combining like terms, making sure that they have the same variable or variables, and each variable has the same exponent. So now we're going to move on to multiplying. So the multiplication of polynomials, so this is a monomial times a binomial. When we're multiplying, we are just distributing. So I am going to be multiplying this front term by the 2a, and then I'm going to be multiplying it by the 3b. And when we're multiplying these, we're really relying on the rules that we learned in Unit 7 for when we're multiplying with like exponents and things like that. So 5b times 2a, 5 times 2 is 10. And then my a and b go in alphabetical order. I don't want to write it as ba, I want to write it as ab. Now I'm multiplying 5b by 3b, so 5 times 3 is 15. And b times b, it's the same base, so I'm adding those exponents, which are each one, to get b squared. It's not a bad idea to always check and make sure you don't have any like terms, but if you didn't have like terms in the beginning, you won't have like terms in your final answer. So that's our final answer there. There's nothing more that we can do. Got another distribution here, or multiplication. So 4x times x to the third. There's no coefficient to multiply by, so that's going to stay a 4. And this has an exponent of 1. So when I add these exponents, this becomes x to the 4th. And then when I multiply 4x times 5, it's just the 4 and the 5 that I'm multiplying here. So that gives me 20x. No like terms. There weren't any in the beginning. I'm done. That's my final answer. I am going to do this first one with you, and then I want you to pause the video and try the next 5 on your own. So for this first one, we're going to distribute 3x to each term. So 3x times 5x squared. 3 times 5 is 15. Adding my exponents, this becomes x to the third. 3x times negative x. There's nothing, well, it's 3 times negative 1, so negative 3. And then x times x becomes x squared. And then 3x times 4. 3 times 4 is 12, and we have to keep that x behind it. There weren't any like terms in the beginning here. There aren't any there. That's my final answer. I want you to try the next 5 on your own. As you get to the end, it's going to get a little bit more complicated. We've got x's and y's in some of the terms. But I want you to try them. When you've finished all of them, unpause your video to check your answers. So here are all of your answers to those final 5 examples. Hopefully you got those correct. These last 2 could be a little tricky. Just remember, when you're multiplying something like x squared times 2xy, you can only add the exponents on the x's. The y just stays there by itself. Kind of similar to over here where you had x's and y's. So we could add the x exponents, add the y exponents, but we have to keep the 2 variables separate. So just a couple reminders as you are working through these. First of all, it sounds silly, but did I perform the correct operation? That is the first thing that you want to check for. And what I mean by that is, did I actually add them? Or did I accidentally try to multiply things? Did I subtract? Did I distribute that subtraction to that second polynomial? So always check and make sure you're doing the correct operation. The next thing you should check your answers for are any like terms. You should not have any like terms left in your answers. So check for are there any like terms, and remember your like terms are your things that have the same variable or variables, and each variable has the same exponent. Going back and looking at this final example, everything has x's and y's, but this x has an exponent of 3, this one has a 2, that one has a 1. So by the x's alone, those are not like terms. And then the same thing, you see that each y has a different exponent. And then the last is make sure your answer is in standard form. So for example, we talked about this in the beginning and I kind of forgot to go back to it. If we look at these 2 examples up here, I only had 1 variable. And so when I have only 1 variable, I want my variables exponents to be in descending order. So this exponent of 5 was the largest, so that one comes first. Then the 3, then the 2. Same thing happened with the a's. There's only 1 variable. I want them in descending order by exponent, so the 4, then the 3, then the 2. It's a little trickier when you have multiple variables. So within each term, your variables have to be in alphabetical order. So in this, where I had x's and y's, I need the x before the y. And then you're going to put them in descending order by alphabetical order. So they're going to go in descending order based on x's variables first. So since x comes first in the alphabet, I need the highest exponent for x, descending to the lowest, and the y's just kind of follow along. The x is really what leads which one comes first. Same thing happened here. They both had x's and y's, but x comes first in the alphabet, so it's descending order by the x's. So that's a little bit more detail on that standard form. It's a little easier to understand when we have some examples that we can go back and look at. So if you thought you missed some of these because you had things in the different order, hopefully you can kind of see how your answer was correct. It just wasn't in the final way that we needed to write it. So now you are ready to get started on your choice board work. I know this video was a little bit long, but there was 3 different operations to cover, so there's a lot of assignments that you can go ahead and give a try.